Hello everyone, welcome to this video. In this video, we are going to learn about RANSAC using OpenMathAI. So, let's get started. What is RANSAC? Random Sample Consensus. Regression is a supervised machine learning algorithm used to predict a continuous numerical value, just like linear regression. However, unlike linear regression, RANSAC is specifically designed to work well when the dataset contains many outliers. It identifies the normal data points, called inliers, and ignores the unusual data points, called outliers, while building the regression model. RANSAC Regression randomly selects a small subset of data points, fits a regression line, and then checks how many data points fit that line within a certain error threshold. These matching points are called inliers. This process is repeated many times, and the model with the largest number of inliers is selected as a final regression model. As a result, the outliers are ignored instead of influencing the regression line. Imagine you want to predict the price of a house based on its size. Most houses follow the normal pattern where larger houses have higher prices. However, suppose a few houses with sizes of 10,000 square feet, 16,000 square feet, 33,000 square feet, and 41,000 square feet are mistakenly listed at an extremely high price because of data entry errors. These are outliers. RANSAC regression can produce accurate predictions even when the dataset contains many incorrect or unusual values. We will use this dataset for the RANSAC regression model. So let's get started. Open OpenMathAI. In this demonstration, we use the house price prediction using RANSAC model. Click Create New Project. Enter the project name as House Price. Choose a folder location to save the project, then click Save. To import your dataset, either click Load Example Dataset or browse for dataset to import your own CSV file. Once the dataset is loaded, verify that it contains all columns before proceeding to model training. Scroll down to view the first 10 rows of sample data. Click Continue to Configuration to proceed. Configure the dataset by specifying the input features and output target. There is also a feature called Ignore, which can be used for columns that should not participate in model training. Select the input and output columns manually, or use Smart Suggest for automatic recommendations. There is one more feature, Signal Diagnostics. There is 3 columns. First one is column. It's tell which features are in the dataset like inputs and outputs name. Second one is VIF. It tells how much correlation of the features. Third column is status if it's okay, moderate, high, redundant, and constant. Review the selected configuration. Click Proceed to Model Design. Choose a model from the available machine learning models. OpenMathAI recommends suitable models and features based on the dataset. For this demonstration, select the RANSAC model. View the model overview, pros, cons, and real-world applications. Click Proceed to Training. You will see the selected model. Click Start Train Models. Review the training configuration. Test data split, which determines a percentage of data reserved for testing and validation. Review the model parameters and pre-processing settings. And also another feature is added that is train from scratch or continue from use model. If you train this model before you use that option. Modify the configuration if required. Click Start Training to begin the training process. After training is complete, review the following performance metrics. R-squared measures how well the model explains a variation in the output data. Range 0 to 1. MSE, mean squared error, measures the average squared difference between actual and predicted values. RMSE, root mean squared error, the square root of MSE. RMSE is expressed in the same units as the output variable, making it easier to interpret. Engine time, the time required for the generated model engine to execute and produce predictions. Lower engine time indicates faster model execution, which is important for embedded systems and real-time applications. Fit quality, an overall assessment of how well the model fits the dataset. It is generally derived from metrics such as R-squared, RMSE, and residual errors. Model accuracy. For regression models, accuracy is commonly estimated using the R-squared value. Example, R-squared equals 0.95 accuracy, almost equal to 95%. Click Fit to Window. You will see 3 types. Fit to Window, comfortable, compact. Then the clear history. If you click that, it will clear the history before its trained model. Another is deselect and select all trained model for export. Click View Curves. You will see the diagram of R-squared residuals and residuals diagram. Click Math and Code Preview. View the generated mathematical equation and source code. OpenMathAI provides expression of the data, detailed explanation of the expression, and an implementation code. Return to the results page and click Deploy Status. Click Export Model. Choose the required export format: ANSI, FMU 2.0, FMU 3.0, Verilog RTL, VHDL RTL, Python Bundle, ONN XHub. You can choose any of these format and export. Thank you. Stay tuned for more OpenMathAI demonstration.